Again, welcome. So let us continue our discussion on time domain analysis of the system. So in this lecture, what we will be covering? We will be covering time response of first order control system to various test signals, right? Now, what is your first order control system, second order control system? So for that, we will cover this point, order of the control system. Now, what is the control system? Control system can be defined by a transfer function. So we know this. What is transfer function? Laplace transform of output divided by Laplace transform of input, right? So here your numerator is a polynomial, right? Polynomial function in S, and denominator is also a polynomial function in S. So completely it is a rational function, that is polynomial by polynomial function. Okay. So to find the order of the system, we need to concentrate the denominator polynomial of the transfer function. Now, what is the degree of the denominator polynomial? So it is nothing but the highest power of the denominator, highest term in the denominator polynomial. So यहाँ पर हमें क्या करना है? In Q of S, that is, let us say denominator polynomial is defined as Q of S as an s raised to n plus an minus 1 s raised to n minus 1 plus dot 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 a1 s raised to 1 plus a0 s raised to 0. Okay. तो इसमें if n is a positive integer which is the greatest power of s, so obviously it is s raised to n, right? तो हमें डिनोमिनेटर का पॉलिनोमियल ऑब्जर्व करना है, और डिनोमिनेटर के पॉलिनोमियल में s का सबसे ज्यादा डिग्री कौन सा है, दैट इज योर ऑर्डर ऑफ द सिस्टम, राइट? सो if s is 0, it is zero order system, means what? S term is absent. If s is 1, the power of s is highest power of the s is 1, it is first order system. If highest power of s is 2, it is second order system. So for an example, let us start with first order system. So yes, okay, yeah. So time response of first order system. Now consider this system, right? So this is your input, this is the response of the system, and this is the feedback path. So if nothing is given, means you need to consider feedback as unity, right? Or yeah. So the transfer function is this. If you observe, this is a negative feedback. So the transfer function is g upon 1 plus g h, but h here is 1, so it is g upon 1 plus g, and g is 1 upon st, right? T is a constant, right? So 1 upon st upon 1 plus 1 upon st, it comes as 1 upon st plus 1, right? Now this is your transfer function. We need to observe the denominator. Denominator में देखिए s का power, what is the highest degree of s in denominator? So here the highest degree of s is 1. So this is your order of the control system, right? Hence it is called as your first order system. Now what is the thing? In this topic we will see time response of first order control system to unit step excitation. Means here in input I am giving as unit step. What is unit step? So unit step is nothing but your yes, u of t, and we know if unit step is there, what is the Laplace transform of unit step? R of s, that is 1 by s, right? So अब अगर यहाँ पर input r of t is u of t, then r of s will be 1 by s, obviously. So we know the procedure, हमें procedure पता है. So how to find the response of the system? So t is defined as c by s, then you just keep r on right hand side, and then c of s is equal to 1 upon st plus r of s. R of s का हमें क्या पता है? Laplace transform पता है. So I am replacing here the value of r of s as 1 by s, because the input is unit step in this equation. So it will become c of s 1 by st plus, instead of r of s I will write 1 by s, right? So हमें क्या करना है? Now we need to find the inverse Laplace transform of c of s is equal to this equation, right? So for that, what I need to do, I will find the partial fraction. So let us define it as a upon 1 plus s plus b upon 1 plus st, and then हम find out करेंगे value of a and b. So how to find the value of a? In this equation, neglect the denominator of a, that is s, and then in this equation you just put s is equal to 0. So whatever value you will get, that will be the value of s. So it will be 1 upon 0 plus 1 is 1. So 1 by 1 is 1. So a is 1. And for finding out the value of b, what you will do? You will just replace this term as, we will neglect this term, and 1 upon s. So what will be the value of s? So value of s will be, just equate this term, 1 plus st is equal to 0, so s will be minus 1 by t, and then 1 upon minus 1 by t will be minus t, so b will be minus t. Okay, you just find it out how to find the partial fraction. Okay, and then this will be 1 by s minus t by 1 plus st. Okay, so we need to find the inverse Laplace transform of this. Now what is inverse Laplace transform of 1 by s? We know inverse Laplace transform of 1 by s is u of t, and then inverse Laplace transform of 1 upon s plus, this is what, e raised to minus t by capital T into u of t. So if you take the inverse Laplace transform of this term, 1 by s का Laplace transform 1 into u of t, and minus 1 upon s plus 1 by t का Laplace transform है e raised to minus t by capital T into u of t. I will take u of t common, and then it will be c of t will be 1 minus e raised to minus t by capital T into u of t. So what is this? This is nothing but your response of the system, when I am giving unit step, okay, as an excitation. So this response consists of both the responses, right? This will have some transient part also, and this will have some steady state part also, right? So what is steady state? Whenever your time will become infinity, when you will substitute t is equal to infinity, right, in this equation, the response you will get is your CSS, that is steady state response. So if you put t is equal to infinity, so c of infinity, this e raised to minus infinity, so 1 upon infinity, so it will be 0. So therefore it will be, this part will become 0, right? Because e raised to minus infinity means 1 by infinity. 1 by infinity is 0, so 1 minus 0 into u of t is u of t, right? So steady state response is u of t, and transient state will be e raised to minus t by tau u of t. We need to neglect the steady state response from this complete response. Whatever remaining is there, that is your transient response. Okay, so if you observe from this point also, this 1, right, this was the input, and then your output is nothing but, yes, 1 minus e raised to minus t by tau. So this line, right, this blue color line, this is your response of the system. Okay, so this will have two parts, right? Until it becomes steady, this response is called as your transient state response, and when it becomes steady, this is called as your steady state response. Right? So this was the equation, or this was the this was the response of the system to unit step excitation, right? So now similarly, now what we will see? We will see the time response of first order system. Okay, now here for which signal, then r of t is t into u of t. What is the signal t into u of t? Yeah, so it is your unit ramp signal. Okay, so again the procedure is same. We have the equation c of s is equal to 1 upon st plus 1 into r of s. Now here r of s is what? 1 upon s square. So I will just substitute the value of r of s here. So c of s will be there, this, right? And then again we need to find the partial fraction. So here it is repeated root, so it will be a by s plus b by s square plus c by 1 plus st. And then yes, we find the value of abc by using the partial fraction method, and then we need to find the, this is your output, right, in terms of s, right? So we need to take the inverse Laplace transform. So you will get c of t. We know c of s, we will get c of t. When we will get c of t, when I will take the inverse Laplace transform, right? So in this equation, to find c of t, I will take the Laplace transform of this equation. So minus t by s. What is the Laplace transform of 1 by s? Again it is u of t. So therefore similarly 1 by s square and t upon s plus 1 by t. So t is as it is, and s plus 1 upon s plus 1 by t का Laplace transform क्या है? E raised to minus t by t into u of t. So finding out the after finding the Laplace transform of c of s, we get this c of t. So what is the c of t? This c of t is nothing but the response of the system when input is ramp signal. So see, what is input? Input is your ramp signal, that is straight line passing through origin. And what is the output? Output, your system will behave Like which system? First order system. Your system will behave like this. Initially the response will be slow, and after some time it will follow the input, right? Output will follow the input. Okay, you just see this is the blue color line which is following the black color line, and this is your yes, this is the output which is following the input. There is some difference, okay, time difference is there, of course. So again we can see the response, right? So just before following this output is following the input, right? So there are two states, right? Once it is perfectly following, it will be your steady state, and before that it will be